So for number 10, the vertex is at -2, 8. And again, this is just a quick review of the stuff that we were talking about on Friday. But if we're writing in vertex form, we already know this much. We know a lot about the equation. Y equals A, which we don't know. But if our vertex is at -2, 8, that means it is x plus 2 quantity squared and plus 8. So the only thing we're missing is A. So to find A, we then take any other point on the graph. This happens to give us 2 points. We don't need them both, but I'll choose 0, 0, because that's always a nice one to work with. I'll plug in a 0 for x and a 0 for y, and that'll allow me to solve for A. So I get 0 equals A times 2 squared, which is 4, and then plus 8. So I just plugged in 0 for x and 0 for y. And so then solving this for A comes out to be -2. And so for this quadratic, then in vertex form, it is y equals -2 times quantity x plus 2 squared plus 8. That is the equation of that graph in vertex form. Now, if we wanted to do this, remember our transformations when we move things up, down, left, and right? And when we were subtracting internally, that meant we were moving the function to the right. So this is going to go to the right 4 units. So to do that f of x minus 4, I'm taking this and just moving it to the right 4 units. So remember that each notch is worth 2. So that will be moved to the right 4 units. So the A value doesn't change because it still is opening downward, still has the same width. The vertex changed because our vertex is now at +2, 8. And so then that equation in vertex form is y equals -2 times x minus 2 squared plus 8. Okay, because the only thing that changed was actually the x value of the vertex. The problem does, though, ask us to write it in standard form. So now I have to take this that's in vertex form and put it in standard form. So to do that, we got to FOIL all this stuff out. So I have y equals -2, and then I'm going to FOIL x minus 2 times x minus 2, which is x squared minus 4x plus 4. And then we have our plus 8 on the end. So I'm just expanding all of this stuff. I'm going to distribute the -2 and then combine my like terms. So I have y equals -2x squared plus 8x minus 8. And then I have my plus 8 on the end, meaning our final answer is y equals -2x squared plus 8x. So that is in standard form. All right, so good example of, vertex form and standard form. And when things are in vertex form, we could obviously ask for the vertex, but I could ask questions like, what is the axis of symmetry? And so for the red graph, the axis of symmetry is at x equals -2. I might say, what interval is the function increasing? It is increasing from -infinity to -2. The function is decreasing from -2 to infinity. The range would be from -infinity to +8. The domain would be all real numbers. So those would all be legit questions for either of those functions. All right, so before I go on, any questions? Doing okay? All right, so I'm gonna draw in, we have a little bit of space here. So I'm skipping over these free-falling object projectile motions because we did a whole separate page on free-falling objects. And I'm gonna go to this blank space here, and we're gonna work on completing the square. So to complete the square, that's just a process. It's a process that helps us to write things in vertex form. So for example, if I had the equation y equals x squared minus 10x plus 16, okay? That's a parabola. That's in standard form. Y equals x squared minus 10x plus 16. I want to write that in vertex form. So to write it in vertex form, we complete the square. What that means is this. This middle term here, the b term helps us find what I'm going to refer to as the magic number for completing the square. To find the magic number, you take half of the b term and square it. So half of -10 is -5, squared is 25. And so let me show you what to do with that magical number, okay? Again, I took half of that term and squared it. So my next line, I'm gonna write y equals x squared minus 10x. And then, since 25 is the magical number, and again, I got that by taking half of that and squaring it. So half is -5, -5 squared is 25. I'm gonna write plus 25 and then minus 25. So I write plus the magic number and then minus the magic number. And then don't forget I have plus 16 on the end. All right, so when we do that, what happens now is I can factor these first three terms. Not only can I factor them, it factors as a perfect square trinomial, meaning it factors into the same thing twice. It factors into x minus 5 times x minus 5, or x minus 5 squared. So I'm going to get y equals x minus 5 squared, okay, because I factored that. And then these two I just add together, so I have -25 plus 16 is -9. It's now in vertex form. So now if we could say the vertex is at 5, -9. We could say the axis of symmetry is at x equals 5. I know that it's a parabola. I know that it opens upward. So if it opens upward, that means it has a minimum. I could say it has a minimum of -9, okay, because it'd be the y value of the vertex. So I could give all of those different ideas once I have the vertex. All right, any questions yet?
So where did you get the 25 from?
Yeah, the 25, the magic number comes from this. you take half of the b term and square it. So you take half of that is -5, that square is 25. And then you add it and subtract it. So half of the b term squared is where the magic number comes from, and then you add that number and subtract that number. All right, I'm going to shrink that way down because I'm going to do another example in this same kind of empty spot here. So we're going to do the same thing. We're going to complete the square for this. Y equals x squared plus 7x minus 3. All right, this one is harder. It's harder because I threw you a curveball. Remember, we take half of that and square it? That's not a nice number, right? Half of 7 is not an integer. But this is a nice thing about completing the square. Follow the process with me. So I'm going to write y equals x squared plus 7x. And then half of that would be 7 over 2, right? Just put it over 2. And then squared would be 49 over 4. I'm going to write plus 49 over 4 minus 49 over 4.
So why is it divided by 4 instead of 2?
So I took, I took half of the b term, so 7 over 2, and then squared. So then you square the top and square the bottom. All right, good questions. So half of the b term squared. Now, maybe you're thinking to yourself, wait, is he crazy? How are we ever going to factor this thing? It actually is much easier than it seems, because it's always going to factor into the same thing. And actually, that same thing it factors into is always half the b term. So it factors into x plus 7 halves times x plus 7 halves, or x plus 7 halves squared. And I still have to add this together here. I have the negative 49 over 4 minus 3. Well, I'm going to rewrite 3 as 12 over 4. So that's minus 61 over 4. And there is our equation written in vertex form. The vertex.
Could you go?
Yeah, go ahead.
Could you go over how you got x plus 7 over 2 squared?
Yeah. So when you, and I know there's kind of a lot of rigid steps to this. So first, to get the 49 over 4, we take half of the b term. So half of 7 is 7 over 2. And then we square it. And that's where the 49 over 4 comes from. Now, in the next step, let me put that back. In the next step, I then have to factor this, which seems a really daunting task. However, when you factor it, it always factors into x plus that b term squared. So it factors into x plus 7 halves squared. Now, you can always FOIL that out to see if you do x plus 7 over 2 times x plus 7 over 2, you will get this. Okay, so it always factors into that. And I know working with those fractions is a bit uncomfortable, so we'll do a couple examples here.
Wait, what about the middle term 7x? Like if you do would be like x squared and then 7 over 2x plus 7 over 2x, right?
Right. Yep. It'd be x squared plus 7 over 2x plus 7 over 2x plus 49 over 4, right?
Yeah.
So 7 over 2 plus 7 over 2 is 14 over 2,
Oh, yeah.
7, right?
Okay.
So no, I mean, it's great that you're thinking it through. You're doing exactly what you should, is think about why that would be. And of course, we have 49 over 4 on the end. Okay, so it does check out. Okay, any other questions before I do another one here? All right, I'm going to shrink this guy down also and move it up top. All right, so let me do one more similar problem. So again, we want to complete the square to write this in vertex form. So we have y equals x squared minus 10x minus 39. So right now, think about half of the b term is 5, and 5 squared is 25. So 25 is going to be like our magical number. Okay, and again, we got that by doing half of the b term and squared. So our next line is going to be y equals x squared minus 10x and then plus 25 and minus 25 and then minus 39. So when we factor, we get y equals x minus 5 quantity squared minus 64. And again, notice like before, when it factored into x minus 5, it's always x and then the b term. Okay, I'm going to have you guys try a couple on a class kick, and then we'll go over them together. And, you know, there'll be varying levels of struggling, but we'll do them. We'll go over them together. And I think a couple times through the process, we'll probably be in pretty good shape. All right, I thought we would go over these together, and looked like many of you were doing pretty well with it. So let's take a look at the first one. First, we want to find the magic number. And to find that magic number, we take half of the b term, which is 6, and 6 squared is 36. So 36 is the magic number. So that means my next step, my next line is going to read y equals x squared plus 12x. And then I'm going to do plus 36 minus 36. And then I have plus 40 on the end. So again, I got that number by taking half of the b term and squaring it. Now, when you factor that first 3 parts, that factors into x plus 6 times x plus 6, which is x plus 6 quantity squared. And then the last two, negative 36 plus 40 is plus 4. So remember, when you factor it, this is always going to be your half of your b term, And that's a really helpful thing to remember when we get into fractions, because you go nuts trying to factor those without remembering that little tidbit when we get into fractions. And so then the vertex is at -6, 4.
Do we need to write that? Because I didn't do any of it.
Yeah, well, it did say find the vertex at the top. So just
Oh,
you'll definitely have to tonight for your homework. Okay. All right, for the next one. All right. My b is -5. So half of that is -5/2. And that squared is 25/4, which is my magic number. Now, some of you are writing that as a decimal. I wouldn't suggest doing that. I think it's better to write as a fraction when you get into the factoring. So I have y equals x squared minus 5x. And then I'm going to do plus 25/4 and minus 25/4. And then minus 6. So don't forget, I got the 25/4 by taking half of the b term and squaring it. And now we need to factor the first 3 terms, which seems really hard unless you remember that it's going to factor into x minus 5/2 quantity squared. I got the 5/2 from half the b term. And I still have to do -25/4 minus 6. So I'm going to cheat here a little bit and write that 6 as 24/4. So I don't have to write another step, giving me -49/4. So our vertex is at 5/2 for our x, and our y is -49/4. All right, any questions on that one? I thought that was, definitely harder than the first one. All right, we'll do the last one here. So my magic number, I'm going to do half of the b term, which is 9/2, squared is 81/4. That is the magic number, 81/4. So we have y equals x squared plus 9x plus 81/4 minus 81/4. And then minus 3.
Can you scroll up to number 2 again? Oh, okay. Never mind. I got it right.
Okay. All right. So now we're going to have to factor that x squared plus 9x plus 81/4, which don't forget that half of the b term is going to be in our factor. So that's going to factor into x plus 9/2 quantity squared. And then I have to do -81/4 minus 3. And I'll write the 3 as 12/4. So that's minus 93/4. So even though we are getting some ugly numbers, like a vertex of 9/2 for our x and -93/4 for our y, it still is doable if you remember a couple of shortcuts.
Wait, isn't it -9/2 for the vertex?
It is -9/2. Thank you. Opposite of that. Thank you very much for catching that. Any other questions?